The Windows Phone 7 is equipped with a GPS interface, and couple that with the Windows Phone Location Service API within the .NET Framework class library. We can use it to determine the latitude and the longitude for the application running on a phone device. So I think you can use this for some pretty creative purposes. In fact, within the last year or two, we've seen some companies that have used geolocation and have been able to allow check-ins at Starbucks, and you become the mayor of this marina or restaurant or whatever the case might be. So unfortunately, however, since the Windows Phone Location Service API relies so heavily on the phone's physical hardware for the GPS, and we're not, in this case, working with a physical phone, we're working with the emulator, we're not going to get a completely satisfying result as we begin to work with this here on our Windows 7 desktop, but we're going to attempt to do it anyway. So in this video, we're going to do the following. We're going to attempt to retrieve the current location of the phone through the Windows Phone Location Service API. And yes, we're not going to be able to accomplish that, but at least we can talk about the approach, how it can be done, and we'll wind up just defaulting the latitude and longitude to a specific location if indeed the application is running in an emulator as opposed to on the physical device someday. And then secondly, we're going to call a web service that will resolve the latitude and the longitude to a city, state, and country. Now, a web service is almost exactly like a method that runs over the internet. Somebody hosts a web service and exposes the code block's name, in a sense, and what parameters it'll accept and what it will return back. We can call that over the internet and then retrieve that result back and do something meaningful with it. So when you think of web service, just think of a method that doesn't run locally, it runs over the internet at some web server in a remote place, and that's exactly what it does. And I'll explain more as we get deeper into this example. So as you can see right now, I have an application. I've already done a little setup work. It's called Geoposition Web Service. You can see that I already have a text block defined. I just emptied out the text property. And I have a button defined, and I just changed the content property, but I left the name button 1 and I left this name text block 1. Okay, so I'm going to double click in the Find Me. The first thing that I need to do is get access to the Windows Phone Location Service API. Now, currently we don't have access to it because the way the .NET Framework class library is built, it's split up into a number of different DLL files or assembly files so that you don't load more of the library than you actually need. With so many classes available, it would just make it really overweight to keep it all in one place and make it all available at the same time. So what we need to do is just pick and choose those pieces that we need and include the DLL file that has that portion of the library included into our project. So we've already, if you've opened up this references folder, that's basically what this is. These are DLL files that have automatically been added to our project when we created a file new project. So the template will add these because it knew that we would need some of these features in almost every application we build. This is the first time we've come across a feature that doesn't fit inside one of these DLLs or doesn't live or reside in one of these DLLs. So we're going to have to add a reference to that DLL, that assembly, within the .NET Framework class library. So I'm going to go up to the title of the project and select Add Reference. And that'll open up the Add Reference dialog. I'm going to scroll down until I find the system.device. There it is. System.device and .dll is implied. If we looked to the path all the way to the right, it would show the full name and as well as the path for that file. And I'm going to click OK once I have that selected, and we'll see it now included here in our Solution Explorer. I'm going to go ahead and close the references back up. I'm going to do one more thing. I'm going to add a using statement for the specific part of this that we need. So system.device.location. So now I should be able to go to my button 1 click event and use one of the classes, the GeoCoordinateWatcher class, called, I'm just going to call this myWatcher equals new GeoCoordinateWatcher. And then here I'm going to do this, var myPosition equals myWatcher dot position. Now we can see here that the position property will return a value of type geoposition of type geocoordinate. I'm going to rely on var to figure that out for me. I'm just going to go ahead and do this instead. Alright, so now I have a object called my position, and I can use this to retrieve the latitude and the longitude, something like this. So my position dot location dot latitude. Alright? So let me set things up just a little bit differently though. So let me start with a double latitude equals 0.0, and then a double longitude equals 0.0. Now I'm going to do this. If my position dot location dot is unknown, so let me start here. I'm going to put an exclamation mark. So if the location is not unknown, then I'll fill up latitude and longitude with my position dot location dot latitude. Whoops, latitude. And then I'll set longitude equal to my position dot location dot longitude. Alright, so this covers the case if we can actually, if the API can determine our latitude and longitude, then let's save those values off. But what if it can't? Well, I could use an else statement here right below it and then set it to some value, but I can achieve the same thing by just initializing it to some location. So I'm going to set it to the latitude and longitude of Redmond, Washington, the home of Microsoft. And let me just make a little note here to remind us what's going on here. In this case, since we're not working with a device, I'll just set a default value. If we cannot get the current location, then we'll default to Redmond, Washington. Great. So that'll remind us why we're doing this, in case we look at it this later and say, what in the world were we trying to do there? Okay. So this is about as much as I can do now. I either retrieve the latitude and the longitude from the phone device. If I'm not running it on the actual phone device, then I've defaulted it to some value so we get some satisfaction by running this example. So now that we have that location information, we need to send it off to a web service to determine the city, state, and the country of this latitude and longitude. How we're going to do that. This is where we rely on a web service. A web service, again, is basically just a method that communicates over the internet, and usually over port 80, or rather over HTTP, just like the rest of the World Wide Web. The conversation between your client application that we're working on right now and the web server that hosts the web service is in an XML format called SOAP, which is short for the Simple Object Access Protocol. Fortunately, you don't have to deal directly with the XML, or rather the SOAP message. Visual Studio and the .NET Framework will hide those from you so that you can work with the web service as if it were any other class and method in the .NET Framework class library. In fact, it's called a proxy class. The proxy class is created based on the information that Visual Studio initially retrieves from the web service's definition the first time you try to connect to the web service using Visual Studio, as we're going to do here in just a moment. So that proxy class then handles all of the low-level details of working with that web service so that we don't have to. Very cool stuff. All right, so let's do this. Now we're going to right-click. Well, before we do that, let me just talk about the web service that we're actually going to use. There is a web service from Microsoft Research called Microsoft Research Maps, and it has two web services. One is for landmarks, so give it, I guess, coordinates, and it'll return you what landmarks are near those coordinates. We're more interested in this MSR Map Service WSDL, and as I click on it, it'll give us this friendly list of all of the methods that belong to this class, but essentially what we need to do is copy this http:/msrmaps.com/terraservice2.asmx. So I'm going to just use Control-C on my keyboard to copy that onto the clipboard. And then what I'm going to do is right-click on my project name and select Add Service Reference. And here I'm going to paste in Control-V that address, and I'm going to select the Go button. And now it's looking over the internet to find that web service and everything that belongs to it. I'm also going to give this a friendlier name. I'll call this My Terra Service. And I'm going to click OK. So now Visual Studio is building that proxy class that we can access from that point on. Now, because I've had some issues with this in the past, I'm going to look at the error list just for a moment. There is a warning here about it's unable to load one or more of the requested types. Retrieve the loader exceptions property for more information. If you receive any more errors than this, then you might have a problem running this example. You might want to create a new project and start over. Just a little issue that I had when I was building this example in the first place. But I think we're going to be okay if that's the only error that we see in our service. You can see now there's a service reference folder with My Terra Service below it. So what we'll do is this. I'm going to call My Terra Service dot Terra Service SOAP client equals new My Terra Service SOAP client. So now we have a reference to a client object, and what we want to do is a little bit more complicated. We're going to need to make what's called an asynchronous call. Alright, so when you make a call over the internet, you can imagine that it might take a long time, depending on the time of day. If in this case the user is going to be contacting it via their phone, so what if they're in a bad connection, or their Wi-Fi connection is really weak at that particular moment? Well, you can imagine that this call across the internet could take potentially a very long time. So what happens while your application is waiting? Well, the phone is basically locked out of taking additional actions. Therefore, in Silverlight, you can call some web services asynchronously, meaning that you listen for an event that fires once the application receives back the response from the web service, if it ever receives it back. Meanwhile, then, the application is free and the phone is free to continue on working until that event happens. So once you've told Silverlight that you're listening for the response in an event that you're going to create, then you're free to call the web service. Once the web service responds, your event is fired, and you should be able to retrieve the result of the web service at that point. So it's kind of a two-step process. You're going to throw the request over the fence and go on doing whatever you want to do, and at some point the response will come back over the fence on your side. You'll be able to pick it up and read it. Okay, so this is just a way to make sure that the phone is not put on locked out or put on hold by your application's call to the web service. While waiting for the response, the phone and your application will continue to work and operate. So fortunately here again, Visual Studio makes this very easy to define a custom event that will handle the asynchronous web service call. And I don't expect you to understand everything that's going on here. Just follow exactly the steps that I take. And if you ever need to do this again, just refer back to these exact set of steps in order to call and work with web services that run asynchronously. So here's what I'm going to do. There is an event handler called convert lawn lat point to nearest place completed. I'm going to do a plus equals, and when I do that, notice that there's a little bubble that pops up to create a new event handler. So Visual Studio is going to make this easy on us. At the very right hand side, which you can't see in the recording area, it says press tab to insert. So I'm going to press tab once on my keyboard, and then it says again press tab to generate the handler client convert lawn lat point to nearest place completed in this class. I'm going to hit tab a second time. So all you need to do is just call that first portion, client.convert lawn lat point to nearest place completed plus equal, and then let Visual Studio do the rest. You just hit tab and tab. Notice what it created for us. It finished out the remainder of this event handler declaration. So it wires up an event handler and says, when this completed event happens, make sure to call my new method called client convert lat lon or lon lat point to nearest place completed. Then when we hit the tab a second time, it created what's called a stubbed out event handler for that purpose. Now you can see also it gives us this throw new not implemented exception. We haven't talked about exceptions, but I'm going to comment that out because I don't think I'm going to need it. I'm going to work right now. That's just as a reminder that, ooh, I forgot to implement that method and I need to write some code here. That's all that's for, it's just a placeholder. And so in here what I'm going to do is I'm expecting to receive back from this web service the result. So I'm just going to set the result. So text block1.text equals the result. And that's all I'll need to do there. But up to this point, I've never really called this web service. All I've done is just set it up so that when I do call it, and it does throw the message back over the fence to us, we're ready to catch it. Now I'm going to go ahead and throw the ball over the fence. So here we go. Client dot convert lon lat point to nearest place async. All right. Now when I pass in, it wants a point of type my Terra service lon lat point. So I'm going to go new lon lat point, and I'm going to use the object initializing syntax lat equals latitude, you know, what we created earlier, and lon equals longitude, what we created earlier. So these values here, I'm going to pass in the creation of a new object of type lon lat point. It's what's required by this web service in order to begin the asynchronous call to the web service. All right, I think that's all we're going to need to do. Let me run the application to see how far we've gotten at this point. And it seems to work. As you can see, we got Redmond, Washington, United States back from our web service. All right, so that's pretty neat, right? Admittedly, there's going to be a lot of things in here that you don't quite understand. If you follow the steps just like I did it, you're going to find that you get some success. And this is a good jumping off spot to learn more about several different topics. First of all, what references are to assemblies. Okay, just like we did at the very first step. How to create a proxy to a web service by adding a web reference in Visual Studio. How to create a reference to or create a new event handler by using this plus equal syntax, and then letting Visual Studio finish it for us by clicking tab one time and then tab a second time. And then using the result that's passed in to the event handler in order to display it or do something meaningful with it at that point. Okay, so several new concepts here. Hopefully that didn't blow you away completely. Again, if there's one or more parts of this that are confusing to you, take some time, look for some more resources on web services, on events, and on the .NET Framework and the .NET Framework class library in general, and why you would need to reference assemblies. But if you follow these steps, you'll get pretty close to where we need to go. Okay, so we've covered a lot of ground in this video. Just hang in there. We're almost done for the day. You're doing great. We'll see you in the next video. Thank you.